Anyone reply me? Students, anyone reply me? The PPT is visible.
Yes, sir. Yes, sir.
Voice is audible.
Yes, sir. Yes, sir.
Okay, thank you, thank you. Okay, so first we recall the last class. So in last class, I start with pigeonhole principle. Is it correct? Okay, what do you mean by the pigeonhole principle? So greater than the number of pigeonholes, then at least two pigeon in a same hole. This is called pigeonhole principle. Just I will show the slide. Okay, after that we see some problems in pigeonhole principle, and after that I start principle of inclusion and exclusion. Okay, then we did one problem in principle of inclusion and exclusion. What do you mean by pigeonhole principle? If m pigeons are assigned to n pigeonholes, where m greater than n, then at least two pigeons must occupy the same pigeonhole. So, in other words, at least that is more than one pigeon in the same pigeonhole. More than one pigeon in the same pigeonhole. We seen problems containing that problem. After that, then problem number two: how many students do you need in a school to occupy the same pigeonhole? At least two students who have the same first two initial. I show this problem, that is already I told that you study yourself. Just go through the proof of the problem. Okay, by using division algorithm and pigeonhole principle, easily you can prove it. Then we study one theorem, that is a result, that is let a and b any positive integer, then the number of positive integers less than or equal to a and divisible by b is as a flow function a divided by b. This is one of the most important result. So we seen some problems. So first problem, direct application of the result. The next problem is not divisible by. Not divisible by means the answer is total number of integers which is less than or equal to that particular number minus the number of positive integers less than or equal to that particular number and divisible by 24. Then this is an important problem because this is a 4-mark problem. Why am oftenly I say that we have a 2-mark or 4-mark. Suppose in number theory for 8-mark problem asked as 4 marks. So in that case you may get this problem as a 4-mark problem. So first you have to find the range. How do you find the range? So the number of integer less than or equal to 3776 minus the number of integer less than or equal to 1975. Then only we get the range. So the remaining things already you know that. Then I will give the homeworks. So yesterday we did only one problem, that is okay. Again I will recall. Okay, today I am going to recall again the principle of inclusion and exclusion. When you see this formula, you may get the fear. Okay, don't worry about that. Okay, when you see the particular case, you can easily understand the easily remember the formula. Okay. Okay, case one, that is there are two sets. That is modulus is nothing but cardinality of the set. So modulus A1 union A2. What is our formula? Modulus of A1 plus modulus of A2 minus modulus of A1 intersection A2. In probability, you oftenly the formula P of A in B is equal to P of A plus P of B minus P of A intersection B. So oftenly we come across this formula. The same similar type instead of P, here we use modulus. That's all. The particular case, second particular case, that is there are three sets: modulus of A1 union A2 union A3, which is equal to. See, when you observe this, for a single set we have a plus symbol. The two sets we have a minus symbol. Then three sets we have a plus symbol. Then four sets we have a minus symbol. Okay. So when you see the three sets A1 union A2 union A3, then first I have to write the single sets, that is modulus of A1 plus modulus of A2 plus modulus of A3. Then I have to choose a collection of two sets, that is minus A1 A2 minus A1 A3 minus A2 A3. Then the three set A1, A2, A3. So easily you can remember modulus of A1 plus modulus of A2 plus modulus of A3 minus modulus of A1 intersection A2 minus modulus of A2 intersection A3 minus modulus of A1 intersection A3 plus modulus of A1 intersection A2 intersection A3. Okay. Now suppose we have four sets. So the same thing. First I have to write the single sets. So A1 first, A2 second, A3 is third, A4 is fourth. Next I have to collection of two sets. From 1 2 3 4. How do you get the collection to? From 1 2 1 3 1 4, then 2 3 2 4 3 4. Already yesterday I show this. That is write 1 2 3 number. From 1 to 2 just I mark arc. Then 1 2 3 again I mark another arc. Then 1 2 4 2 2 1 3 1 2 4 2 2 3 2 2 4, then 3 2 4. Okay. So problem 1. So we see in problem 1, find the number of positive integer which is less than or equal to 2076 and divisible by neither 4 nor 5. Before enter this problem, first of all we have to know two things. We know the formula only for divisible by, because the number of positive integer less than or equal to some number and divisible by some number. For this case, I have a formula. As well as சார் சொல்லுங்க சார்.
சார் ரெக்கார்ட் இன்னும் பண்ணல சார். மேம் கிட்ட சொல்லிடுவா ரெக்கார்ட் பண்ண சொல்லி. ஹலோ.
இல்ல பண்ணிட்டு இருக்காங்கன்னு நினைக்கிறேன். ரெக்கார்டிங் வந்துச்சு எனக்கு. சார் ஒரு நிமிஷம் சொல்லுங்க. கேக்குதா சார்?
கேக்குது சார், கேக்குது சார்.
பண்ணிட்டு இருக்காங்க.
ஓகே ஓகே சரிங்க சார், கண்டினியூ பண்ணுங்க.
ஓகே 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 ஓகே. Okay. So problem 1, the number of positive integer less than or equal to 2076 and divisible by neither 4 nor 5. Neither 4 nor 5. Okay. So in that case, we have to clear about two things. One thing is principle of inclusion exclusion. Principle of inclusion exclusion. So in that formula we have only union. Okay. So as well as we know the one formula, that is the number of positive integer less than or equal to some number and divisible by some number. So we have these two things. By using these two things, we have to solve the given problem. Okay. See here, find the number of positive integers less than or equal to 2076 and divisible by neither 4 nor 5. Okay. So in that case, first we have to assume two sets. See, in each and every problem, principle of inclusion and exclusion. So first I have to consider two sets or three sets. Here we have to find divisible by neither 4 nor 5. So I have to choose two sets, set A and B. The set A is nothing but, so the set of all integer which is less than or equal to 2076 and divisible by 4. Set B, the number of positive integer less than or equal to 2076 and divisible by 5. Okay, so here we have to find divisible by neither 4 nor 5. That means it's not divisible by 4 and not divisible by 5. We need not divisible by 4 and not divisible by 5. Okay. So how do we get this? Because and means I have to use intersection, but we have the formula in terms of u. So the given is not divisible by 4 as well as not divisible by 5. In that case, I have to think about the opposite statement. What is the opposite statement of not divisible by 4 and not divisible by 5? The opposite statement is at least that number is divisible by 4 or 5. At least that number is divisible by 4 or 5. R means unions. So now we have the formula A union B. Okay, so just apply the formula A union B, that is modulus of A plus modulus of B minus modulus of A intersection B. So modulus of A is nothing but the number of positive integer less than or equal to 2076 and divisible by 4. The formula is floor function of 2076 by 4. The second one, cardinality of B, that is modulus of B. That is a floor function of 2076 divisible by 5. And how do you get modulus of A intersection B? That is nothing but the number of positive integers less than or equal to 2076 and divisible by 4 as well as 5. So that means equation we have modulus of A union B is equal to 831. So modulus of A union B means the set of all positive integers which is less than or equal to 2076 and divisible by 4 or 5. Okay, but we have that is not divisible by 4 and 5. How do you get this? So first we have to find the total number of integers. Then from that I have to subtract the number of positive integers less than or equal to 2076 and divisible by 4 or divisible by 5. So the total number of positive integers is nothing but 2076 minus the number of positive integers less than or equal to 2076 and divisible by 4 or 5, that is 831. If you subtract it, you will get 1245. That is the set of all 1245 integers which are less than or equal to 2076 and divisible and not divisible by 4 or 5. Okay. Okay, next problem. Problem 2. So up to this we see in the last class. Problem 2 is newer one. Okay. What's the problem 3? Find the number of positive integers less than or equal to 3000 and divisible by 3, 5 or 7. That means the number of positive integers which is less than or equal to 3000 and divisible by 3 or 5 or 7. Divisible by 3 or 5 or 7. So R means as well as I have to use union symbol. Okay. So so this is direct formula. So modulus of, because here there are divisible by 3, divisible by 5, divisible by 7, there are 3 terms. So I have to take 3 sets. That is my set A means the set of all positive integers less than or equal to 3000 and divisible by 3. What is the set B? The set of all positive integers less than or equal to 3000 and divisible by 5. What is the C? The set of all positive integers less than or equal to 3000 and divisible by 7. These are all set A, B, C. Then I have to apply the formula. So what's the formula? Modulus of A union B union C, because we need the number of positive integers less than or equal to 3000 and divisible by 3 or 5 or 7. That means I have to use the formula union. So A union B union C. The formula is modulus of A plus modulus of B plus modulus of C minus modulus of A intersection B minus modulus of B intersection C minus modulus of A intersection C or C intersection C. Both are same. Then plus modulus of A intersection B intersection C. First write the values, then I will give you a technique to quickly solve this problem. Okay, that is just write it. What is modulus of A? That is floor functions of 3000 by 6, because A means set of all positive integers less than or equal to 3000 and divisible by 3. Similarly, what is your B? The floor function of 3000 by 5. What is your C? The floor function of 3000 by 7. What is your A intersection D? Floor function of 3000 by 3 into 5, 15. Then what is your B intersection C? So 3000 divided by 5 into 7, 35. Then what is your C intersection A? That is floor function of 3000 by 3000 divided by 3 into 7, that is 21. Then what is your A intersection B intersection C? That is 3000 divided by 3 into 5 into 7, that is 105. So after writing this, easily you can, I will give the technique. Via technique, you can do the problem quickly. You can complete. First, you have to find the calculation for 3000 by 3. So, okay, 3000 by 3 is nothing but 1000. So, floor function of 1000. Next, don't find the value of 3000 by 5. Instead of that, just find the value of fourth value. That is 3000 by 15. Because already we have 3000 by 3. Then divided by 5, you will get the value of the fourth term. Because we have to find 3000 by 15. Okay, so first to find the value, after that just apply divided by 5, you will get the fourth value. Then divided by 7, you will get the seventh value, 3000 by 107. Okay, so at a stage you can able to find 3 values. The next one, just find the value of 3000 by 5. After that, find the value of 3000 by 35. That is 3000 by 5. Again apply 7 divided by 7. You will get 3000 divided by 35. Okay. Then similarly 3000 by 7, after that just find 3000 by 7, again divided by 3, you will get 3000 by 21. Okay, then 3000 by 105 already we found, so just find the values and calculate it. Finally you get 1629. Okay, so this is your answer for the number of positive integers less than or equal to 3000, then which is divisible by 3, 5 or 7. The answer is 1629 integers which are less than 3000 and divisible by 3 or 5 or 7. Okay, so see, one thing you have to know that instead of inclusion exclusion, we have the formula for union. Okay, so either the question is asked for union case, or you have to find total number of integers minus that formula containing union. So if you subtract it, you will get the answer. Only there are 2 cases. Okay. Then next one is so homework problem. Okay, anyone try to answer for this one, because already you studied this thing in your DM also. Okay, find the number of integers between 1 to 250, both inclusive, that are not divisible by any integers 2, 3, 5, 7. How do you solve this problem? Please, anyone reply me. Please, anyone reply me. Students, anyone reply me. Hello, any students, please reply me. No one reply me. Okay. Okay, I will explain. So find the number of integer between 1 and 250, both inclusive, that are divisible by any integer 2, 3, 5 and 7. Okay, that is the number of integers between 1 and 250 both inclusive that are not divisible by any integer 2, 3, 5 and 7. Here we have to find not divisible by, but we can able to find the value. We have the formula for only divisible by. First you have to find the number of integers between 1 to 250 that are divisible by at least one of 2, 3, 5 and 7. So we have to find not divisible by 2, 3, 5 and 7. But we can able to find divisible by at least one of the integers. Okay. Uh, so for this we know the formula A union B union C union D. So we need not divisible by case. That is how do you evaluate this? Total number of integers minus the number of integers between 1 and 250 that are divisible by at least one of the 2, 3, 5, 7. So total number of integers is nothing but 250 because we have 1 and 250. Okay, so this is nothing but formula of A union B union C union D. What is your A? The set of all positive integers that is lies between 1 to 250. Then which are divisible by 2, that is for set A. Divisible by 3, that is for set B. Divisible by 5, that is for set C. Divisible by 7, that is for set D. Okay, clear? Just do it. This is a homework. Okay, next. So up to this we covered a major topic, that is one is division algorithm, the another one odd and even integer. Then after that because in first class itself I give the subtopics. From the subtopics, the first topic is division algorithm. We see already we seen that. Then after that I teach you odd and even integer. Then later I covered pigeonhole principle. So after that I covered the principle of inclusion exclusion. So under first topic there are 5 subtopics. This is the last subtopic of first topic, first session. We can say that the division is the first session. Okay, the last topic is principle of mathematical induction. Principle of mathematical induction. So already you studied these things in your school itself. Okay. Let P of n denote the mathematical statement that involves one or more occurrence of the variable n which represent a positive integer. So there is some statement, okay, in terms of n. So I denoted that statement as P of n. How do you prove this statement? So there are 3 cases. First is basic step, that is for n equal to 1 we have to prove the statement. We have to show that it is true. Then this induction step, that is we have to assume P of k is true, then we have to prove that P of k plus 1 also true. If you prove like this, then we can say that P of n is true for all n which is belongs to set of all positive integers. Okay, so already we know very well about this, very well about these things. So once I recall, when n equal to 1 we have to prove the statement is true. When n equal to k we assume the statement is true. Then when n equal to k plus 1 we have to show that the given statement is true. Then finally we conclude that the statement is true for all set of all positive integers. Okay. Then first problem, prove that 2 into n cube plus 6n square plus 7n is divisible by 3. Okay. So I can consider this is f of n. My f of n is 2n cube plus 6n square plus 7n. So the proof is by mathematical induction. What's our first step? For n equal to 1, the statement is true. Fn is 2n cube plus 6n square plus 7n is divisible by 3. Here you have to write it. Fn is nothing but 2n cube plus 6n square plus 7n is divisible by 3. You have to write the full statement. When n equal to 1, put n equal to 1. What do you get? If you put n equal to 1, 2 into 1 cube plus 6 into 1 square plus 7 into 1. Finally, what do you get? 2 plus 6 plus 7, which is 15. 15 is divisible by 3. So when n equal to 1, f of 1 is divisible by 3. For n equal to 1 case, we proved the statement. Okay. What's the next step? This is induction step. For n equal to k, the statement is true. We have to assume for n equal to k, the statement is true. So assume f of k is divisible by 3. We have to assume f of k is divisible by 3. Then we have to prove that f of k plus 1 is divisible by 3. If we prove f of k plus 1 is divisible by 3, then finally we conclude that 2n cube plus 6n square plus 7n is divisible by 3. Okay, now I have to, for that I have to find f of k plus 1. So what's the f of k plus 1? In f of n, just replace n by, in f of n, we can replace n by k plus 1, we will get f of k plus 1. So 2 times of k cube plus 3k square plus 3k plus 1, just apply 6 into k plus 1 whole square, so k square plus 2k plus 1 plus 7k plus 7. So simplify, then after that just, so if you simplify, what do you get? Finally 2k cube plus 7k square, then, okay. So up to this you will get it. After this, what I have to do? So this is first step, this is second step, this is third step. Up to third step, no problem. So the fourth step, you have to arrange like that. Fourth term, you have to arrange like that. So how do you arrange the fourth term? So already we assume f of k is divisible by 3. That means 2k cube plus 6k square plus 7k is divisible by 3. So you have to use this thing in f of k plus 1. Then only we can able to prove it. So that means from f of k plus 1, I have to arrange the element 2k cube plus 6k square plus 7k is separate one, remaining is separate one. Then only I can say that by assumption this is divisible by 3, then think about the remaining. Okay, if I arrange like this, because how do you arrange this? From this step, so see the previous step, that is assumption step, that is f of k is 2, that means 2k cube plus k square plus 7k is divisible by 3. We know that result. You have to use that result, then only we can prove the result. Okay, from this I have to arrange the statement of f of k is true. That is, you have to keep 2k cube plus 6k square plus 7k separate, bring the remaining term. When you observe the observe the remaining, it clearly says that the 3 is common, so you can take it out. So when you observe this one, so easily understand this is divisible by 3, this term is divisible by 3, this is divisible by 3. Finally, we can say that f of k plus 1 is divisible by 3. So 2k cube plus 6k square plus 7k is divisible by 3, and 3 times of 2k square plus 6k plus 5 is also divisible by 3. Finally, we conclude that 2n cube, finally we conclude that f of k plus 1 is divisible by 3. Hence, 2n cube plus 6n square plus 7n is divisible by 3. I think you know clear about this proof. Okay, did you understand? Do you have any doubt? Can I move on to next problem? Okay, just I move on to next one. So this is a little bit different. Okay, this is it's not a the proof of this problem is not similar to previous problem. It's slightly different. Okay, if 4x minus y is a multiple of 3, we know that 4x minus y is a multiple of 3. We have to prove that 4x square plus 7xy minus 2y square is divisible by 9. How do you prove this? Okay, anyone please reply me at least for this question. No need to unmute your mic, then answer me. So no need to put the result in the chat box. Please unmute and then reply me. So what's the difference between problem number 1 and problem number 2? Anyone find the difference between problem number 1 and problem number 2? Please reply me. Please, anyone unmute your mic and reply me. What is the major difference between problem 1 and problem 2?
Sir, in problem 1, that is one variable, sir. Here 2 variables.
Exactly correct. Okay. Good ma. Thank you. See, in problem 1, we have one variable, that is the statement contain the variable n only. But in problem 2, we have two variables, say x and y. Okay. See, okay. But we know the procedure for only one variable. We have a procedure for mathematical induction for only one variable. Okay. How do you solve the problem? by mathematical induction. For applying mathematical induction, I need a statement which is involved in one variable. How do you convert like this? The given is 4x minus y is a multiple of 3. By using this only, I can able to convert this as a single variable. Convert into single variable. It's a very easiest one. Okay. See, if 4x minus y is a multiple of 3, then show that 4x square plus 7xy minus 2y square is divisible by 9. So given that 4xy is a multiple of 3, that is 4xy is multiple of 3 means 4xy equal to 3 times of some integer, say m. From that, I can convert y in terms of x. How do you convert y in terms of x? Keep this y to the right hand side and keep 3m to the left hand side. Finally, we arrive at y equal to 4x minus 3m. So now I have a conversion from y to x. So apply this conversion in 4x square plus 7xy minus 2y square. We will get 4x square plus 7x into 4x minus 3m plus 2 into 4x minus 3m whole square. Just solve it. Finally, we arrive at 27mx minus 18m square. Okay, 20 because here 4x square 28x square minus 32 is become 0. Then here 48xm. Okay, minus 40. Here there is a minus symbol is missing. Okay, minus 48xm. Sorry, here you will get a plus 48xm. Here I have minus 21xm. Finally, we arrive at 27mx minus 18m square. So when you observe this term, what I have to prove that this expression is divisible by 9. So I see whatever the expression divisible by 9 means, the expression should be in terms of 9 into something, 9 into some integer. So from this expression, you have to bring out 9 outside. If you bring out 9 outside, the problem is over. So there is any possible for taking out 9 outside? Yes, there is a possible. Because here 9 is, for both term, we have a common is 9m. So take it out 9m outside. So 9m into 3x minus 2m is clearly 4x square plus 7xy minus 2y square is divisible by 9. This is a little bit different problem compared to the previous one. Okay. So what in the problem, suppose they gave 2 variables, definitely you have to convert 2 variables into single variable. The hint will be given in the question also. By using the hint, you have to convert the 2 variable into 1 variable. Okay. So do you have any doubt in this problem? Okay. Now I can move on to another problem. Some people you may do you have any doubt?
So
tell me, Sanjay. I think Sanjay.
Yes, sir. There isn't any PMA used here, sir. So
okay. You are asking. So in the previous case, I consider PM for n equal to 1 is true. For n equal to k, we have to assume the statement is true. So
yes,
that is
sir.
You asked. Is it correct?
Yes, sir. We are not using PMA here itself, sir.
Okay, no problem. It's because for this problem we have a more work on this statement, that is 4x square plus 7xy. See, in previous case, okay, I will explain. Can you say that 2n cube plus 6n square plus 7 is divisible by 3 directly?
No, we can't.
But here we can able to say that 4x square plus 7xy minus 2y square, we can say that directly this is divisible by 9. How? This expression converted into 9 times of m into 3x minus 2m. So it is enough to say that this expression is divisible by 9. No need to go for mathematical induction.
Okay, sir.
Okay. So in previous problem we cannot say directly because we don't know about the n, where n is a positive or negative. We don't know about. Okay. Because suppose here is a multiple of 3. Here is a multiple of 3 means we can say directly this is divisible by 3. Okay.
Yes, sir.
Okay. So this is a little bit different problem in principle of mathematical induction. Okay. Thank you. Okay, the remaining all our problem, see, only one hint I will give you for any problem given by principle of mathematical induction, you can easily solve it. The concept is for n equal to 1, you can easily show that that is true. Then for n equal to k, you assume the statement is true. For n equal to k plus 1, you have to prove that the statement is true. When n equal to k plus 1, you have to prove the statement. Is true. For that, you have to apply the statement P of k is true. Okay, we assume P of k is true, so you have to use the hint. Then only we can prove the P of k plus 1 is true. Okay, so in the derivation of P of k, P of f of k plus 1 or P of k plus 1, you have to use the result of P of k plus 1 is true. Then only we can prove that P of k plus 1 is true. Okay. So just two simple homework using induction method, prove 4 power 2n plus 10n minus 1 divisible by 2n. Similarly, by using the using induction proof, see always they asking the first problem is the some expression divisible by 25. The next problem is some expression is an even integer. So some expression is an even integer means definitely that expression divisible by 2. You have to show that that expression is in terms of 2 into something. In terms of 2 into something. Then we prove the result. Okay. So so first one easily you can prove that. Just do it yourself. You can easily get the answer. Okay. Up to this. The topic 1 division algorithm. Under the topic division algorithm, we have 5 subtopics. All the subtopics are covered. Okay. So this is another 2 mark by using summation. So evaluate summation D, where D is divides 12. It's a simple one. So what is the summation? Tells that summation I have to sum the D value, where D is nothing but D divides 12. That means I have to find the divisor of 12 and then sum it. This notation is nothing but, this is nothing but sum of the positive divisors of 12. Okay. So first to find the divisors of 12, then add it, you will get the answer. Okay. So what is the next one? Sigma D divides 12, 1. That means, see here I have to sum the 1 value. So summation varying is on the divisors of 12. That means this is nothing but a number of positive divisors of 12. This notation is nothing but number of positive divisors of 12, because I have to add the value 1. How long I can add it? The number of divisors of 12, that length I can add the value 1. So that is nothing but number of positive factors of 12. Okay. So this is, there are 6 factors of 12, because 12 is divisible by 1, 2, 3, 4, 6, 12. So there are 6 factors of 12. Okay, then this is another summation. Sigma sum the value of 1 by D, where D is the divisor of 18. So what are the divisors of 18? 1, 2, then 3, then 6, then 9, then 18. So just 1 by 1, 1 by 2, 1 by 3, 1 by 6, 1 by 9, 1 by 18. Just find the LCM, we'll get the answer. This is a simple 2 mark. So, but these 2 things very important in Unit 5. So we are going to study Unit 5. In Unit 5, there are major classical 3 theorems. So in the one of the theorems says that there is some. How do you find the number of factors in number of factors of a number? What is the sum of the positive factors of a positive number? So both the definition we will use in Unit 5. Okay. So up to this, we covered all subtopics in my first topics. Okay, I will show you the first slide. Okay, so this is Unit 3 syllabus. First section is first section is division algorithm. From that section, there are 5 subtopics. The division algorithm already we seen that. This the theorem is important 8 mark problem. The Pigeonhole Principle is a 2 mark problem. The statement are problems. The mathematical induction sometimes 8 mark problem, sometimes 4 mark problem. Principle of inclusion, exclusion also sometimes 4 marks, sometimes 8 marks. The odd and even integer is a 2 mark problem. Okay. So now because we across 4 periods, out of 4 periods I cover only 1 topic from Unit 5, that is division algorithm. Okay. Next, base B representation, the topic number 2, base B representation. So we will see later, because already you know very well about that is BSB representation, and number pattern is easiest one. So I will teach you later. BSB representation as well as number pattern. Okay, next I move on to the topic prime and composite number. Okay. Anyone please reply me. What do you mean by prime number? Anyone please reply me. What do you mean by prime number? Give the definition of prime number or give the examples of prime number. So whenever I start one particular topic, I have to interact with you because I have to give more knowledge on that particular topic. You may know that, sir. We studied the last class also. I inform you. You don't think that this is all I studied in school itself. Okay, we have to study in deep in your engineering subject. Okay, so only we recall all these things. Okay, please anyone reply me. What do you mean by prime number or define prime numbers?
Numbers which has factors other than 1 in itself.
Other than, please reply again.
Numbers which doesn't have any factors other than 1 in itself.
1 in itself. Okay, give some example.
For example, 2, which is even prime number. And another example is 5 or 7.
These are all odd prime numbers. Okay. So, please mute your mic. So, other than Sanjay, please answer me. There is any possibility of negative prime number or positive prime number, or only we have positive prime number, or we have only prime numbers? That is, we have, see, for example, in even integers we have positive even integer, we have negative integer. In odd integer we have positive odd integer and negative odd integer. In prime number we have positive prime number as well as negative prime number, or we have only a positive prime number itself. Other than Sanjay, please answer me. Anyone, unmute your mic and then answer me. Don't bother about whether your answer is correct or not. Okay, please reply me. Try to answer me. Then only you can get some knowledge. See, out of 158, definitely at least few of them have a doubt. There is only positive prime numbers. There is no negative prime numbers. Some people may have a doubt. I want to clear that doubt to all your students. So only asking question to you. So prime numbers definition is, prime numbers means the only factors are 1 in itself. Okay. Now tell me, there is any existence for negative prime numbers?
No, sir. No, sir.
Okay, why? Suppose -2 is a prime number or not? First of all, -2 is a prime number or not?
Sir, we don't have negative factors.
Right. See, listen, Sanjay. Vignesh,
yes, sir.
This is Vignesh?
Yes, sir.
Okay, tell me.
There is no negative factors, so we cannot have a negative prime numbers, I think so, sir.
There is no negative factors, sir. See,
so.
Okay, in this section I will teach you what do you mean by factor. Okay. Any other one? -2 is a prime number or not?
So can I?
No. It's a simple one. See, நல்லா படிச்சிருந்தா, அதாவது நான் திருப்பி சொல்றேன், இந்த கொஸ்டின் என்ன கேட்டா கூட நான் படிக்கிறதுல நான் சொல்லியிருக்க மாட்டேன். ஓகேவா? Okay, I am an average student. Okay, so நான் என்ன சொல்றேன், you have to learn the deep knowledge in each and every simple topics. Okay, because you are going to write a program. So if you want to write the program with no error, you have the deep knowledge in each and every mathematical concept. Okay, then only you won't get any error or any errors. Okay, so please anyone reply me whether -2 is a prime number or not, -2 is a negative prime number or not. Out of 158, no one know the answer?
No, sir.
Why, ma?
2 இப்போ 2 ஓட மல்டிப்ளை ப்ரைம் நம்பர்ஸ் கூட மல்டிப்ளை பண்ணா இன்னொரு இன்னொரு நம்பர் கிடைக்கும் சார். எனக்கு தெரிஞ்சு அது நெகட்டிவ் கிடையாது சார். அது நெகட்டிவ்
ஓகே
ப்ரைம் நம்பர் கிடையாது.
ஐ
எனக்கு
அக்செப்ட் யூ. புரியுது நீ சொல்றது
அது
கரெக்ட்.
என்ன
ஏன்னா நிறைய பேருக்கு
எதுக்குன்னு
தெரியும்.
தெரியல.
ஓகே நிறைய பேர் தெரியும் -2 இஸ் நாட் அ பிரைம் நம்பர். ஆனா எனக்கு எப்படி சொல்ல தெரியல அப்படிங்கிற ரைட்டா?
ஆமா சார்.
ஓகே குட். ஓகே எனி அதர்? Try to find the reason. You exactly said -2 is not a prime number. You have to find the reason. Your sister and brother something or your junior -2 is not a prime number. I know that, but I cannot prove that, or I cannot give the explanation for that one. அப்படின்னா உனக்கு கஷ்டமா இருக்காதா?
Sir. Sir.
Tell me, ma. Reply me.
Sir, 1160.
Okay, ma'am. Okay. I will give the answer and then conclude my session. Okay. -2 is not a prime number because find the factors of -2. What are the factors of -2? What are the factors of -2? Sanjay, please reply me.
1 -2 -1 2.
That's all. The factors of -2 are -2, -1, then 1, then 2. There are 4 factors. But what is the definition of prime number? We have only 2 factors, 1 and itself. Okay, yes, so in prime number, there is no negative prime number. We have only a positive prime number, or simply prime number. They didn't, what I said, there is no concept of positive and negative prime number. We have only a prime number means it's a definitely positive number. Prime number means definitely it's a positive integer. Okay, so the prime number means the only divisors are 1 and itself. That's all. This is a basic concept. Okay, so யாருக்கு எந்த டவுட் இருந்தாலும் தயவு செய்து பேசு, ரிப்ளை பண்ணு. Then only you can learn deep knowledge in a simple topic also. Okay, so here I conclude that prime number means the only divisors are 1 and itself. The negative number cannot be a prime because it has more than 2 factors. Okay, so up to this I conclude this session. So we will see the next session. Please, only 20 students upload the first class notes in the Google Classroom. Remaining, what about the remaining? So whatever I teach here, you have to copy in the notebook and take the photo and send to the Google Classroom. Please do it. Then only you can get some knowledge. Okay, so classல எப்படி காப்பி பண்ணியோ அதே மாதிரி ஸோ இங்கேயும் நான் நடத்துறத நோட்டில் ஒர்க் அவுட் பண்ணு. நோட்டில் ஒர்க் அவுட் பண்ணி பார்த்துட்டு ஒர்க் அவுட் பண்ணி தென் ஃபோட்டோ எடுத்து எனக்கு அனுப்பு. ஓகே, தட் இஸ் அப்லோட் பண்ணு கூகுள் கிளாஸ் ரூம். ஓகே, தேங்க்யூ ஸ்டூடெண்ட்ஸ், தேங்க்யூ. நவ் யூ கேன் லீவ் த செஷன்.
தேங்க்யூ சார்.
சார் யாராவது இருக்கீங்களா? ஹலோ சார், ஜெயக்குமார் சார் யாராவது இருக்கீங்களா? சார் யாரும் லைன்ல இருக்கீங்களா? மீனாட்சி சார்.
And President Ibrahim Boubacar Keita's forces are firing at will. The security forces have killed at least 11 protesters. The demonstrations first broke out on June 5th. People called for President Keita's...
ஜெயஸ்ரீ மேம், சுபா பேசுறேன்.
ரெக்கார்டிங்க கட் பண்ண முடியுதா பாருப்பா.
அதுதான் மேம் இப்ப நான் பாத்துட்டு இருக்கேன். மேக்ஸ் ஸ்டாஃப் யாரும் இல்லையா?
கூட்டிட்டு போயிட்டாங்க. மேக்ஸ் ஸ்டாஃப் யாருமே இல்ல. நானும் இப்பதான் பாக்குறேன். க்ளோஸ் பண்ணாம போயிட்டாங்க.
இங்க எனக்கு ஸ்டாப் ரெக்கார்டிங் கொடுத்துட்டுமா?
உங்க நேம்ல வருதா? அது பாத்துக்கோ.
இல்ல, உங்க நேம்ல அந்த ரெக்கார்டிங் will be saved in Dr. D Jayashree Google Drive.
உங்க இதுல வருதா? சரி, நான் பாஸ் பண்ணிக்கிறேன்.